Okay, when working with trigonometric ratios, we first need a right triangle. And the main three trig values we're going to start with are sine, cosine, and tangent. Now that funny zero in there with the little line in the middle, that's called theta. That's a Greek letter. So here we've got a right triangle. Notice angle A has been labeled theta. And then the longest side in there, the green one, is called the hypotenuse. The side with the hypotenuse that is making angle theta, that's called the adjacent. And the side across from theta is the opposite. And we have a nice little mnemonic device for remembering trig values. So, which means sine is the opposite side over the hypotenuse. Cosine is the adjacent over the hypotenuse. And TOA, tangent, is opposite over adjacent. And then we can also take the fraction, the ratio, and turn it back into the degrees. Because if we can add something, we can subtract it. We always have inverse operations. So sine inverse of the fraction opposite over the hypotenuse will get us theta. It means cosine inverse of the adjacent over the hypotenuse will get us theta. And tangent inverse of the opposite over the adjacent will get us theta. Now, first couple examples, given the triangle below, what are the values of the following? Well, we want to find sine of p, cosine of p, and tangent of p. Well, remember our SOHCAHTOA. Sine is opposite over hypotenuse. Well, let's see. There's p. The side opposite it is 12. The hypotenuse is 37. Cosine would be the adjacent over the hypotenuse. Well, we already know the hypotenuse is 37. The adjacent would be the only other side that we've got, 35. Tangent would be opposite, which is 12, over the adjacent, which is 35. Okay. Given the triangle in example 1, what are the values of the following angles rounded to the nearest degree? Well, angle R, we could work with that and deal with it as if we were looking for its sine, and that would be 35 over 37. So sine inverse of the opposite over the hypotenuse, so 35 over 37. Plug that into the calculator and we get about 71 degrees if we round to the nearest degree. And measure of angle P, again, I can just use sine inverse, and we have that ratio up at the top, 12 over 37, so sine inverse of 12 over 37 is about 19. Now let's check that. 71 plus 19, well, 71 plus 9 is 80, 80 plus 10 is 90, plus 90 gives us 180. That adds up to all the angles in the triangle, so it works. Example 3, given the triangle, what are the lengths of the indicated sides? Well, here we're setting up a little bit differently. Looking for x, again, SOHCAHTOA. X is the adjacent, we have the angle is 51, and we have the hypotenuse, so that means cosine would work. Got the angle is 51, we don't know x, but we do know the hypotenuse is 12. Now to get x by itself, we multiply both sides by 12. So that gets us 12 times the cosine of 51 degrees equals x. If we just type that in the calculator, we get 7.6. You do have to make sure that your calculator is in degree mode. There are two different modes, degree and radian. Most of your problems you're working with degrees, not radians. Now for y, with the same angle, we can work with sine, because that's the opposite side. So sine of 51 equals y over 12. Again, multiply both sides by 12. And 12 times the sine of 51 degrees equals about 9.3. Now, given the triangle below, and a equals 5, b equals 12, c equals 13, what are the values of the following? Well, let's fill in. We got 5 there, 12 there, and 13 there. So sine of a, opposite over hypotenuse. Opposite is 5, hypotenuse is 13. Cosine of a would be adjacent, which is 12, over the hypotenuse is 13. Tangent is opposite, which is 5 over 12. Sine of b, well, b is down there at the bottom, and opposite it is 12, so that would be 12 over 13. Notice the sine of B equals the cosine of A when we're working with the same triangle. So that kind of means cosine of B should equal the sine of A. And cosine of B adjacent is 5, hypotenuse is 13. That works. Tangent of B, that's just going to be 12 over 5. Now, a little bit more application type. We've got a boat observed from the top of a 150-foot high cliff moving away from the cliff. The angle of depression of the boat changes from 45 degrees to 14 degrees in 2 minutes. Find the speed of the boat to the nearest foot per second. Well, we've got a couple triangles. We've got this first one where how far away from the cliff it happens to be is x, because we don't know that distance. And we know that the angle of depression is 45 degrees, so to figure out what angle is left, 90 minus 45 is 45. And then we've got a bigger triangle, still 150 feet. That total distance away from the cliff is y. That angle of depression is 14 degrees, so 90 minus 14 tells us that we've got 76 degrees left for that. Now the relationship we've got, we don't have the hypotenuse in either case, so both of these are tangent problems. Tangent of 45 equals x over 150. Tangent of 76 degrees equals y over 150. Solve both of those for x and y, so multiply both sides by 150, and we get x is about 150 and y is about 602. Total distance that the boat traveled, well, the total distance at the end from the cliff to the boat is 602, and it was originally 150 feet from the cliff. So subtract those two. Gets us 452 feet is how far the boat traveled. Now, distance is rate times time, so that means rate is going to be distance divided by time. We know our total distance traveled was 452, and that was in 2 minutes. And so we get R is about 226 feet per minute. That's the rate. Except I don't want feet per minute. I want feet per second. So I got to get rid of minutes. So we take 226 feet per minute times 1 minute over 60 seconds. That'll get us, the minutes will cancel and we'll get feet per second, which is about 4 feet per second. Now, practice 1 is a lot like example 4 and example 1 and example 2, so you can work through those. Practice 2 is very similar to practice 1 through 4, or through example 1 through 4. Okay. And last but not least, practice 3 is exactly like practice 5. I want you to try your best, but this is kind of a challenge one that I'm looking at as well.